Okay, so this chapter is all about similar figures, and one of the things you have to be able to do with similar figures is set up and solve proportions. So we're just going to take a minute here and review how to solve proportions using, oops daisies, the cross product, also known as the butterfly method. Sometimes people think of it that way. So we can talk about how that looks here. So we have, that should not say x over 4 minus 3/8. That should say x over 4 equals 3/8 is what that actually should say. So let's fix that first of all. That should say equals there. And if we are going to use the cross product or the butterfly method, we just multiply diagonally. 8 times x is 8x. 4 times 3 is 12. And we're going to divide both sides by 8 to get x by itself, which is 12/8. And if we wanted to simplify that a little bit more, we could take a 4 out of the top and the bottom and get 3 halves, or 1.5. Okay, again, just another one here, a couple of examples here. We've got 12 over x. Now the x is in the denominator, but that doesn't really matter. We're just going to butterfly diagonally, and we get 3 times x is 3x. 12 times 5 is 60. And we're going to divide 3 on both sides to get x by itself, and we get x equals 20. Down here, they look a little bit more difficult, okay, but not really. We just have to remember to distribute when we're doing our cross product. If we have 3 times 2 is 6, and then 5 times x plus 3, we have to make sure that we distribute that 5 to both parts, and we get 6 equals 5x plus 15. Don't forget to distribute it to that second part, and then we can subtract 15 from both sides, and we get negative 9 equals 5x. If I divide both sides by 5, we're just going to leave that as a fraction, negative 9/5. Last one, okay, we're going to multiply diagonally. 12 times 3 is 36. Negative 7 times 4 minus x. You have to make sure we distribute that through. 36 equals negative 28 plus 7x. If I add 28 to both sides, I get that over here on the right is still 7x. That's going to be 64, and we can divide by 7 on both sides, and we get that x equals 64 over 7. And unless the directions specifically tell you otherwise, you can just leave it as a fraction. Okay, so now we're going to talk about shapes being similar to each other. And if they are similar, that means that all pairs of corresponding angles, okay, we've talked about corresponding angles in a previous chapter, all pairs of corresponding angles are going to be equal. And on our exploration that we did, we found that as we made those different pentagons, that the angles were always going to be equal, even as they got bigger or they got smaller. All pairs of corresponding sides have the same scale factor. Okay. Also, altitudes, medians, and midsegments have the same scale factor. And one other thing, perimeters also have the same scale factor. So then the question is, well, what in the world is a scale factor? Okay, so what is a scale factor? The scale factor is the ratio or fraction. Remember, a ratio is just a fraction that compares corresponding sides of similar figures. We use the variable k to represent scale factor. Kind of like we use m for slope, we use k to represent scale factor. So if we look at these two triangles, they are similar to each other, and it says, what is the scale factor? Well, let's look at our pairs of corresponding sides. So JK corresponds to PQ, QR and KL correspond, and then JL and PR correspond to each other. So we could pick any pair of corresponding sides, and we should get the same fraction. So if we look at the reds, 6 9, we're going to write that as a scale factor or a fraction, so 6 over 9. If we chose the blue, we would have 4 over 6. And if we chose these greens, we would have 8 over 12. But what you need to realize is that if, as you simplify these fractions, 6/9 simplifies to 2/3. 4/6 simplifies to 2/3. 8/12 simplifies to 2/3. So our scale factor is that simplified fraction, that same ratio for all sides, comparing from one to the other. Okay, one other thing is when we have scale factors, we have similar figures, we can write what is called a statement of proportionality. Okay, so we're going to write, first of all, I'm going to do what we just did on the last slide, and we're going to figure out what is the scale factor. Well, really, we only need to pick one pair of corresponding sides to find the scale factor. We don't have to do all of them. So if I said TR and ZX, they correspond to each other. So I could say 25 over 15, and when I simplify that, I get 5/3. Again, just a quick look here, 30 over 18 would also simplify to 5/3, and 20 over 12 would also simplify to 5/3. So it doesn't matter which pair you use as long as they correspond to each other. So my scale factor is going to be 5 over 3. And then what we just want to realize is that the corresponding angles are congruent, so the pairs of corresponding angles from one triangle to the other are going to be congruent. So we could say that angle T is congruent to angle Z. Okay, those two are correspond to each other. We could also say angle R is congruent to angle X, because they correspond, and then S and Y. So we could say angle S is congruent to angle Y. Okay, so now a statement of proportionality, you have to be a little bit careful with, okay? But a statement of proportionality is where you write each pair of corresponding sides, their names, not their lengths, as equal ratios or as fractions. So it's going to be a series of 3 fractions that are equal to each other. Okay, so we're going to have one fraction equal to a second fraction equal to a third fraction, and it is going to be segment names, not their values. Okay, so if we look at our diagram here, I have marked in red TR, I'm going to do this in color, TR and XZ. Okay, that's one pair of corresponding sides. That's the first fraction in our statement of proportionality. Then I have TS and ZY, so that's going to be my second fraction in my statement of proportionality. And then my bottom one here is RS and XY. So that's going to be my third. Again, they are segment names, and they are just corresponding from one to the other. And since there are 3 sides, there will be 3 fractions in that statement of proportionality. Okay, so take a second here. I want you to finish this slide and figure out what is the scale factor, list the congruent angles, and write a statement of proportionality. So please pause the video and write out these 3 things, and then when you start the video again, you can check to make sure that you did it correctly. Okay, so if you notice, our scale factor should be 2/3. No matter which pair of sides you use, you should have got 2/3. My congruent angles, J is congruent to P, K and Q, L and R. And my statement of proportionality, if you noticed, I color-coded them up here. The blues equal the proportion of the red equals the ratio of the green. So just double check that you have that correct. Okay, so when these 2 figures are similar, you can set up a proportion. So we did review how to solve proportions for a reason. You can set up a proportion to find missing side lengths. So in order to set up a proportion, we only need 2 ratios. We need 2 fractions that are going to be equal to each other. And of course, one of them should be the side that has x in it. Okay, so I'm going to say I have the corresponding sides EF and MP, or excuse me, NP. So I have x over 30. Okay, that's just going from my top shape to my bottom shape. And then on the other side, I could either have 15 over 18, or I could have 20 over 24. It doesn't matter which one you have, 15 over 18, okay? We could also set it up as x over 30 equals 20 over 24, and either way, we will get the same answer. So when we do our cross product, we would have 18x equals 450, okay? So if we had 450 divided by 18, x is 25. Okay, the other way, we would have 24x equals 600, and just double checking, 600 divided by 24 had better be 25, and it is. So either way, you can set it up a couple of different ways, but just make sure that if I go black to black, I have to equal red to red or blue to blue. You can't mix the reds and the blues together and have it work if you're going to set it up that way. Okay, so go ahead, take a minute, okay, pick which sides you want to have as part of your proportion, set up a couple of proportions, and solve for x. Okay, so take a look at how I set them up. Now notice my red marks and my blue marks. You might have used different sides. However, when you set up your proportion and solve it, you still should have ended up with the same answer. If you did not, please make sure you ask so I can look at how you have your proportion set up and make sure you set it up and solved it correctly. Okay, we said on that first slide that perimeters also share that same scale factor, okay, which means we can set up a proportion using perimeters just like we can with the scale factor. So if we are going to use perimeter, we can do the ratio of the perimeters of the two shapes. So we have perimeter of A over perimeter of B. It's going to equal your scale factor from one to the other. So here I don't even need to have that x there, so I'm going to cross that out so we don't have anything that we need. So we are not able to find the perimeter of gazebo A. So we're going to call that x, okay? And we do know the perimeter of this one. If we add them up, what do we get? So the perimeter, if we add 15 plus 9 plus 12 plus 15 plus 18, we get 69, okay? How do we find our scale factor? Well, we take one side from gazebo A and the corresponding side from gazebo B, so our scale factor is 10 over 15. Notice I'm going from left to right. I'm going from the smaller one to the bigger one. And if we simplify that, our scale factor is going to be 2/3. I just took a 5 out of the top and the bottom on there. So if we're going to look at this formula, right, on how to figure it out, we're going to compare our perimeters. Okay, perimeter A of gazebo A. We don't know, so we're going to put our X there. On the bottom is the perimeter of our gazebo B. Well, we do know that is 69. Over here, we are going to put our scale factor. Since we have our small on top, big on the bottom, we're going to have our small on top, 2 over 3. And we can go ahead and cross product to solve that. 3x equals 138. And if we divide by 3, what do we get? 138 divided by 3 is 46. So our perimeter of our smaller gazebo is 46. Okay, one more time here. All right, we're going to need our scale factor. Our scale factor K, the only two sides we have are 6 and 9, so our scale factor is 6 over 9, which again is 2/3. Not all the scale factors will be 2/3, they just happen to be that way. So we don't know the perimeter. All right, so I went small to big, right? So I went from left to right. So I do know the perimeter of this shape on the left is 24. I don't know the perimeter of the shape on the right. So I can say that the perimeter of this, I'm going small to big, I'm going to say 24 over x equals 2 over 3. And be careful, you can't just always assume that x is going to be in the top. And when we go ahead and multiply that out, we get 2x equals 72, and x is going to be 36. So the perimeter of this is 36. And the perimeter of that one is 24. And if you look at it, that kind of makes sense, right? That one's a little bit bigger. Okay, areas, however, are a little bit different, okay? Areas are a little bit harder. You can't just set them up. You have to do a little bit of work. So our formula here is we're going to have the area of our first shape over the area of our second shape. And if you remember, areas are squared. Remember, it's meters squared, centimeters squared, units squared, whatever it happens to be, which means on our, when we have our corresponding side lengths, these side lengths, when we write that scale factor, we have to square it, okay? So our area of the one on the left, it says is 36. We don't know the area of the one on the right, so we'll call that x. So our area of figure 1 is 36. Area of figure 2 is x. Okay, so we just went 36 over x. And then we need to use our corresponding side length from figure 1. So we're going to have basically this right here is our scale factor. So we're just going to basically square our scale factor. So we're going to have 10 over 5 squared. Okay, it's just a little bit of exponent stuff here that we need to remember. Okay, so we have 36 over x. Inside our parentheses, if we simplify that, is 10 divided by 5, which is 2, and we have to square it. Okay, so we have 36 over x equals 4 over 1. Notice I put that over 1, so I remember that x is in the bottom, my 4 is in the top. And then I remember when I cross product, I would have 4x equals 36, x equals 9. So the area of my smaller triangle over there is 9 centimeters squared. So let's look at one more here. Okay, so we have our scale factor, okay, is 7 over 21, and we have our area of that rectangle on the left, and we don't know the area of the rectangle on the right. So the area, so we're going to go area over area. So we're going to go 84 over x. Okay, that's our area equals our corresponding side lengths. We're going to have 7 over 21, but we can't forget those side lengths. In order to make our units match, we need to square it. Okay, so we can look at this a couple of ways here. So we have 84 over x. If we simplify this fraction inside of here, 7/21 or 7/21, we get 1/3. But we still haven't squared it yet. All I did was simplify it. And I need to keep that 84 over x here. I haven't done anything with that. And if you remember from exponent rules from Algebra 1, this squared has to be distributed to everything on the inside of the parentheses. So my numerator is going to be 1 squared, which is just 1. My denominator is going to be 3 squared, which is 9. Okay, so our cross product here, we're going to get x equals, if we take 84 times 9, we get 756 meters squared. Okay. So if you notice, basically, that if you're looking at a ratio here, the rectangle on the right is 3 times bigger than the rectangle on the left. That might give you an indication of how much bigger your answer should be as well. So just don't forget, when you're using area, you have to square those side lengths. And when you're using perimeter, side lengths, corresponding sides, anything like that, you do not have to square it. But oftentimes kids forget that squared right there. Good luck.